All right, looks like we got cut off a little bit, so we're going to make this part 2 of looking at mole fractions and partial pressures. We had already found the mole fractions, if you will recall. So now we're going to look at finding the total pressure by using PV equals nRT. So if we write PV equals nRT, and then we're going to manipulate the equation. So P is equal to nRT divided by V. Then we're going to add the values. So the number of moles is 6.19. Remember, that's what we found as the total pressure once we added up, the total moles after we added up the two amounts of helium and oxygen. Then we use the gas law constant, and the temperature is 298. That was in the earlier problem right here. Then we also see that the volume is 12.5 liters, so we put 12.5 liters at the bottom. Moles cancel, liters cancel, and Kelvin cancel, so we're left with atmospheres. Okay? What that ends up with is 12.1 ATMs if we're going with 3 significant digits. And that is now our total pressure. Now that we know the total pressure, we can apply the mole fraction to find the partial pressure. Okay? And the partial pressure is basically taking the mole fraction times the total pressure. So if we want to find the partial pressure of helium, we take the mole fraction of helium and multiply it by 12.1. So we set that up. 0.977 times 12.1 ATM is equal to 11.8 ATM. And there's our partial pressure of helium. Okay? We're going to do the same thing for oxygen. So we basically take the mole fraction, 0.0218 times 12.1, and we get 0.263. Now because we're multiplying this, there's 3 significant digits in both, so we have 3 sig figs. Now if we wanted to check our work, we wanted to see if the partial pressure of the 2 gases added up to the total pressure, we just have to add these numbers. And when we do, we get 12.06. And you might say, well, that's off a little bit. But you have to remember, since we're adding these, we can actually only do 1 decimal place. And so we round it up to 12.1, and our significant figures actually give us the right answer. Okay? Now, one last thing I want to talk about is, what if you are given partial pressures? How do you find the mole fraction? It's not that difficult. All you have to do is take the ratio of partial to total. So you basically take the partial pressure of helium, which is 11.8, divide it by the total pressure, which is 12.1, and 11.8 over 12.1 is 0.977, which we already found to be the mole fraction for helium. So that's how you would go in the opposite direction. Good luck, and hopefully that was helpful.